Installing a receptacle in a drawer is indeed possible and often implemented in kitchen islands or bathroom vanities where counter space is limited. The method involves several steps. Firstly, cut a hole in the side or bottom of the drawer, ensuring it is large enough to accommodate the receptacle box. Secondly, install a shallow receptacle box within this hole. Thirdly, carefully fish the wires through the box and securely connect them to the receptacle. Finally, gently push the drawer back into its designated place. The benefits of this installation are significant. It provides convenient access to electrical outlets without cluttering countertops. This keeps cords neatly out of sight, reducing potential tripping hazards and maintaining a cleaner aesthetic. Regarding exposed wires, these are commonly observed during construction or remodeling projects. There are several reasons why an electrical box might not be immediately installed. 1. The electrical work might be in progress and not yet complete. The installation of the box is often scheduled for a subsequent phase of the project. 2. In certain situations, standard electrical boxes might not be suitable, particularly when dealing with thicker walls. In these cases, a remodel box is necessary, which requires a larger cutout to accommodate its design. 3. Leaving a wire stubbed out provides greater flexibility for future modifications. This approach allows for the convenient addition of lights, fans, or other electrical devices without the need to create new holes in the walls or ceilings. 4. Code requirements at some jurisdictions mandate the use of an electrical box for all electrical connections, even those that are capped off and not immediately in use. It's crucial to adhere to the National Electrical Code, or NEC, requirements regarding box fill and conductor termination. The NEC specifies the maximum number of conductors, devices, and fittings allowed in an electrical box to prevent overheating and ensure safe operation. The NEC also dictates how conductors should be properly terminated to prevent loose connections and potential electrical hazards. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidelines related to electrical installations. When working with electrical wiring, safety should always be the top priority. Before starting any electrical work, always disconnect the power supply to the circuit you will be working on. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical shock and other hazards. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to perform the work. It is essential to consider the specific type of receptacle box suitable for drawer installations. Shallow receptacle boxes are designed to minimize the depth required behind the receptacle, making them ideal for drawers where space is limited. These boxes are typically made of plastic or metal and come in various shapes and sizes to accommodate different types of receptacles. When selecting a receptacle box, ensure that it is listed by a recognized testing laboratory such as Underwriters Laboratories or ETL Semco to ensure that it meets safety standards. When fishing wires through the receptacle box, use appropriate tools and techniques to avoid damaging the wires or the box. Wire strippers are essential for removing the insulation from the ends of the wires without nicking or cutting the conductors. Use needle nose pliers to bend the wires into the correct shape for connecting to the receptacle terminals. Ensure that all wire connections are tight and secure to prevent loose connections and potential electrical hazards. Proper grounding is crucial for electrical safety. The grounding conductor, typically a green or bare copper wire, provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Ensure that the grounding conductor is properly connected to the receptacle box and the receptacle itself. In the context of exposed wires, it's important to differentiate between various scenarios. Temporary wiring may be used during construction or remodeling for temporary lighting or power tools. This wiring is typically run above the ceiling or along the floor and is not intended for permanent installation. Temporary wiring must comply with specific NEC requirements, including proper insulation support and protection from physical damage. Abandoned wiring refers to electrical wiring that is no longer in use and is disconnected from the power source. The NEC requires that abandoned wiring be removed from accessible locations such as attics and crawl spaces to prevent potential hazards. Regarding remodel boxes, also known as old work boxes, these are designed for installation in existing walls or ceilings where access is limited. Remodel boxes typically have mounting ears or clamps that secure the box to the wall or ceiling without the need for nails or screws. These boxes are available in various sizes and shapes to accommodate different types of devices and wiring configurations. When using a remodel box, carefully cut the opening in a wall or ceiling to the correct size, ensuring that the box fits snugly without being too loose or too tight. Secure the box in place by tightening the mounting ears or clamps. When planning for future flexibility in electrical wiring, consider the potential need for additional outlets, lighting fixtures, or other electrical devices. Run extra wiring to strategic locations throughout the building to accommodate these future needs. Cap off the ends of the wires with wire connectors and tuck them into electrical boxes for easy access when needed. Clearly label the wires to indicate their purpose and destination. When leaving a wire stubbed out for future use, protect the end of the wire with a wire connector or electrical tape to prevent accidental contact with live voltage. Tuck the wire into a safe location where it will not be damaged or create a hazard. The NEC provides specific guidelines for the installation of electrical boxes in various locations, including walls, ceilings, and floors. The NEC specifies the minimum size and type of box required for different wiring configurations and device types. Ensure that the electrical boxes are securely mounted to the building structure to prevent them from becoming loose or damaged. When installing electrical boxes in damp or wet locations, use weatherproof boxes and fittings to protect the wiring from moisture. When working with electrical wiring, it's essential to understand the different types of conductors and their ampacity ratings. Conductors are typically made of copper or aluminum and are available in various sizes, expressed in American wire gauge or AWG. The ampacity of a conductor refers to the maximum amount of current it can safely carry without overheating. The NEC provides tables that list the ampacity ratings of different conductors based on their size, insulation type, and installation conditions. When selecting conductors for an electrical circuit, ensure that they are properly sized to handle the expected load. Overcurrent protection is essential for protecting electrical circuits from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. Circuit breakers are resettable devices that can be tripped manually or automatically. Fuses are one-time devices that must be replaced after they have blown. The NEC specifies the maximum size of overcurrent protection devices allowed for different types of circuits and conductors. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock by detecting ground faults and interrupting the flow of current. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of exposure to moisture. GFCIs can be installed as receptacles or as circuit breakers in the electrical panel. Arc fault circuit interrupters, or SIs, are designed to protect against fires caused by arcing faults in electrical wiring. SIs are required in certain locations, such as bedrooms, to provide an additional layer of fire protection. Electrical permits are often required for electrical work, especially for new installations, alterations, or additions. Check with your local building department to determine whether a permit is required for your project. The electrical inspections are conducted by qualified electrical inspectors to ensure that electrical work complies with the NEC and local electrical codes. Schedule an electrical inspection after completing your electrical work to ensure that it is safe and compliant. Proper planning is essential for a successful electrical project. Before starting any electrical work, develop a detailed plan that outlines the scope of the project, the materials required, and the steps involved. Consult with a qualified electrician or electrical engineer if you need assistance with planning your electrical project. Obtain all necessary permits and approvals before starting any electrical work. Follow all applicable codes and regulations to ensure that your electrical work is safe and compliant. Maintain accurate records of all electrical work performed, including wiring diagrams, equipment specifications, and inspection reports. These records will be helpful for future maintenance and troubleshooting. Periodically inspect your electrical system for any signs of damage or wear. Repair or replace any damaged or worn components promptly to prevent potential hazards. Keep electrical panels and equipment clear of obstructions to allow for easy access and ventilation. Educate yourself and others about electrical safety to prevent accidents and injuries. Never attempt to repair electrical equipment if you are not qualified to do so. Always hire a qualified electrician for any electrical work that you are not comfortable performing yourself. Always remember to turn off the power to the circuit you are working on before you begin. Double check that the power is off by using a voltage tester. Use insulated tools and equipment when working with electricity. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. Avoid overloading electrical circuits by plugging too many devices into a single outlet. Use extension cords sparingly and only for temporary purposes. Inspect extension cords regularly for damage and replace them if necessary. Never run extension cords under rugs or carpets where they can overheat and cause a fire. Keep electrical cords and equipment away from heat sources and flammable materials. Teach children about electrical safety and keep them away from electrical outlets and equipment. Install tamper-resistant receptacles in areas where children are present. Cover unused electrical outlets with outlet covers. Never allow children to play with electrical cords or appliances. Keep electrical appliances away from water sources, such as bathtubs and sinks. Never use electrical appliances while taking a bath or shower. If you experience an electrical shock, seek medical attention immediately. Report any electrical hazards to the appropriate authorities. Be aware of the signs of electrical problems, such as flickering lights, sparking outlets, and burning smells. If you notice any of these signs, have your electrical system inspected by a qualified electrician. Regularly test ground fault circuit interrupters to ensure that they are functioning properly. Replace batteries and smoke detectors and carbon monoxide detectors regularly. Have your electrical system inspected by a qualified electrician at least every 3 to 5 years. Electrical work can be dangerous, so it is important to take all necessary precautions to protect yourself and others. By following these safety tips, you can help to prevent electrical accidents and injuries. Always consult the latest edition of the National Electrical Code, or NEC, and local electrical codes for specific requirements and guidelines related to electrical installations.